From geometric series, we derived different formulas for different types of functions. For example, 1 divided by 2 plus x has power series representation, -1 to power n, x to the n, divided by 2 to power n plus 1. When you plug in 0, what do you get? You get -1 to power 0, x to power 0, which is 1. So you get 1 divided by 2. If you plug in 1, you get -x divided by 4. If you plug in, for example, 2, you get x squared divided by 8, and so on. So by using the geometric series, we can find power series representation for different types of functions. In general, you can see the pattern this way as well. You can say that, hey, as long as I have the summation of a quantity, like a box, is just a quantity to power n, and start from 0 to infinity, this can be written as 1 divided by 1 minus that quantity, as long as the absolute value of the quantity is less than 1. Okay, so in this example, in this question, we have the following scenario. It says, find a power series representation for x cubed divided by 2 plus x. How do we find power series representation here? First of all, if we rewrite x cubed divided by 2 plus x as x cubed times 1 divided by 2 plus x, we already have power series representation for 1 divided by 2 plus x, which is the summation of, on top, we have -1 to power n, x to the n, divided by 2 to power n plus 1, and start from 0 to infinity. And remember that for this guy, the absolute value of x is less than 2. This is what we showed before. This is basically this example in previous session that we did. Now, if you just multiply this power series by x to the third, you are done. Now, multiply the power series -1 to power n, x to the n, divided by 2 to power n minus 1, n plus 1, and start from 0 to infinity by x to the third. And then we're done. So let's see. Here I have x to the third multiplied by the power series, the summation of -1 to power n, x to the n, divided by 2 to power n plus 1, and start from 0 goes to infinity, which is basically the multiplication of x to the third by the terms of this series. But the terms of the series, as we saw, is basically written this way. When you plug in n equal to 0, we saw that the very first term becomes 1 divided by 2. When n is equal to 2, the second term becomes -1. Let's plug in 1 first. You get -1 to power 1 times x divided by 2 to power 2. When n is equal to 2, you get -1 to power 2, x squared, 2 to power 3. When n is equal to 3, you get negative 1 to power 3, x to the third divided by 2 to power 4 plus the rest of the terms. So what are you basically doing? You're basically just distributing x to the third into parentheses here. N equal to 0, n equals to 1, n equals to 2, n equals to 3. Now just distribute this guy into parentheses and see what happens. It only changes the exponent of x. So this is written as x cubed divided by 2 minus x to the fourth divided by 4. And here you have plus x to the fifth divided by 8 minus x to the sixth divided by 16 plus the rest of the terms. So what are we basically doing? We are basically just adding 3 to 1 to n here. So you're just adding these exponents. So the series can be written as the summation of negative 1 to power n, x to power n plus 3 divided by 2 to power n plus 1, and start from 0 goes to infinity.